Okay, so for this problem, we've been looking at it, calling it common second difference. And it's also a common difference. Common difference is kind of a broad category that a lot of them will fit into. Common second difference gives you a lot more information that you went to the second level of subtraction until you got all the same numbers. So I'm going to write some of that on my paper. And let's get to that right now. Let me put it back on the document camera for you. So I'm going to call this common difference. A common difference, this can refer to, or maybe instead of can, I should say does. Does refer to several types of sequences. And I'm not real crazy that I wrote the word several in there, because it can be almost an infinite number of types of sequences. This can be arithmetic. Here's an arithmetic sequence. I'm going to start with 5. I'm going to add 6. 5 plus 6 is 11. What's 11 plus 6? 17. 17 plus 6? 23. 23 plus 6? 29. Blank, blank, blank. So on the test next week, give the next 3 terms. What would you write? 35, 41, and then 47. And if I look, I got plus 6, plus 6, plus 6, because I wrote it that way. So if I have only one level until I get the same number, I'm adding 6 each time, that's called an arithmetic sequence. But it also fits the category of a common difference. So I'll put, this is an arithmetic sequence. And it is also a common first difference. I would expect you would call it arithmetic. Just arithmetic gives a lot more information. Well, they give the same information, but it gives a lot more than just saying common difference. For something like this, could you give an expression for the nth term? Okay? For the nth term, I would look at this and say this is term number 1, this is term number 2, this is term number 3, this is term number 4. And then for the nth term, anybody know what the expression for the nth term will be? The nth term is not n plus 6, would be 5 plus 6, open parentheses, n minus 1. What I would suggest you do for that is put this in a little table and do what we did last week. We're about to do it exactly. I would say this for you. Put this in a little table. I just go with the vertical table. because I have more space to write as I work out toward the right side of the page. The first column is the term number. The second column is the term. The first term was 5. So term number 1, the term is 5. Term number 2, the term is 11. But don't look at 11. Look at how you got 11. Like 11 is 5 plus 6. The next term number is 3, and the term was 17. But don't look at the final result. Look at how you got 17. Well, that was 11 plus 6. And 11 was 5 plus 6, so 5 plus 6 plus 6. And then term number 4, that's 23. But don't look at the 23. Look at how you got 23. 23 was 17 plus 6. 17 was 5 plus 6 plus 6, so one more 6. The fifth term was 29. But don't look at 29. Look at how you got 29 from the previous term. You added 6. Previous term was 5 plus 6 plus 6 plus 6, so one more plus 6. Look for a connection between the number of 6's. How many are there right here that I've circled? 4 of them. 4 of them. Look for a connection between the number of 6's and the term number. In fact, I could write this 29 as 5 plus 6 times 4, since multiplication is repeated addition. What is the connection I'm looking for? The number of 6's is 1 less than the term number. So the nth term should be 5 plus 6, open parentheses, n minus 1.